So I'm going to talk about artificial intelligence. So I'm going to begin by defining what I mean by intelligence and what I mean by human intelligence first. So I'm going to define the way I think about intelligence is activities, like Koopman's activity analysis. Activities. So there's three activities that I'm going to identify with intelligence: pattern recognition, or you could think about that as data compression, generalization, and then decision making, which uses the outputs from the first two. So here's a paradox. I'm going to talk about artificial intelligence, but before I do that, I'm going to ask, who created artificial intelligence? Well, people like us. And Steven Pinker, the cognitive psychologist at Harvard, has identified, when he talks about the purposes of education, purpose of education is to overcome our cognitive disabilities as human beings. So we have evolved as hunter-gatherers from tens of thousands, if not hundreds of thousands of years, and we're good at certain things. And we have theories of statistics, biology, economics, and physics that are good for hunter-gatherers. They're terrible for modern life. That's what he says. So we're bad at statistics, biology, economics, and physics. I won't define those. So what tools do we use to create artificial intelligence? So the sources of artificial intelligence and machine learning, if you drill down and look at what's created it, are statistics, biology, economics, and physics. So the irony or paradox is that we're bad naturally at the things that AI is using to make us artificially intelligent. I think that's beautiful, ironic, and maybe troublesome. So what's under the hood of AI? If you look under the hood of AI, so go look at what is underneath AlphaGo or AlphaFold. Look at what tools are there. And what you'll find is tools that are taken from those four disciplines that I mentioned. Prices and values, makes an economist feel good. Prices and values. Game theory, alpha-beta pruning, distributed computing, dynamic programming, big time, dynamic programming, Monte Carlo simulation, competition and survival of the fittest. Check where those came from. And now I'll just go fast. A good thing to look at is John Holland, the great computer scientist from Michigan. In the 1980s, he had an artificial mind. And look at it. He used genetic algorithm. By the way, the genetic algorithm was used by the person who discovered exoplanets to guide his statistics. Ledgers, competing if-then statement, auctions, randomization, exploration, and exploitation. All of those things that are used. So, now the question is, artificial intelligence is very good at pattern recognition. That's what it's been very good at. And essentially, what is artificial intelligence? It's AI, deep neural nets. They're learning a function from X to Y. Y equals f of x, and f is a complicated function. X may be a big vector or tensor, or y may be the same thing. You want to learn that function? AI is designed to do that. Xiaohong Chen's been doing that, for 30 years, using very similar techniques. And your mistake was not calling it AI, that was your mistake. Okay, so is AI good? Well, so the answer is, are patterns enough? Are patterns enough? Okay. Now, this is I was just asked by a very intelligent person about causation. And what's causation? And the question is causation just patterns or not? And you get the smartest philosophers in the world, and you get two answers to that. Yes. David Hume said, all you mean by causation is patterns, period. Particular kind of intertemporal pattern. Some other people say no, and that has not been decided. So for some purposes, the answer is yes. For other purposes, patterns are no. So, so to understand the limitations of artificial intelligence, it helps to have a standing on what the division between yes and no is here. So I'm going to mention Richard Feynman's metaphor. So, the great physicist Richard Feynman, who did breakthroughs in quantum mechanics, which he never understood. He said he never understood, and he never understood what he was doing. And he used some math, which Yao Hong Chen would say is bad. But it works. So she can't understand it, but he used it to discover things about the universe. So Richard Feynman, someone asked him, a person who knew no physics, math, but was an intelligent person, said, tell me what you do every day. What are you doing every day when you're at the whiteboard scribbling those equations? So here's what Richard Feynman said he did. He used a metaphor. He said, it's like a person who doesn't know the rules of the game of chess. Think of the rule Go. So that person watches two people play one game of chess. I'm watching, and I record a data set. Those are my data. From those data, the observer is asked to infer the rules of the game of chess. So think about that, or the rules of Go. So what Feynman said is, that's what I try to do. Think of astronomy. I have some observations, and from those I'm trying to figure out, those incomplete observations, I'm trying to, the laws of nature, the rules that nature is using to generate those observations. And what he said was, that's hard. So was that just pattern recognition, or was it more? So what's the relevance of Richard Feynman's metaphor? Well, the first thing is, we could spend the rest of the time here. That metaphor is exactly what a structural econometrician does. He or she takes data and writes down a game that he took the definition from von Neumann and Morgenstern, tries to figure that out. And, Lars Hansen and various people have been doing that for a long time. And to do that takes big acts of faith, and it's not just, there's no AI that's come close to generating a Lars Hansen. Okay, so AI is very good at detecting and organizing patterns. So far, it's not good at inferring rules of the game. That's a sweeping statement, and I hope to be proved wrong. So, nevertheless, many jobs do involve tasks that are about detecting and organizing patterns. So some jobs, that's all it is. But there's other jobs that are more like Richard Feynman. So I'm going to come back and talk about, can software replace people? Okay, so come back. I'm going to take a digression. So I went to a high-tech conference on machine learning, and people were using deep neural nets. The best people in the world were using deep neural nets to compute equilibria. They were using to solve what I call equilibrium Markov models. What's an equilibrium Markov model? What it is, it's a coherent set or collection of Markov decision problems defined on a common state space. Think about that. That's everything Ariel Packus tries to do, or everything Bob Lucas tried to do. It's a bunch of agents. An agent, what is an agent? It's a Markov decision problem. What's a Markov decision problem? Go look up in a book. What's a coherent collection? They have to fit together. That's an equilibrium. Okay. So one way to summarize that, the way young guys would summarize that, they would say that's just a master equation. Go look up at master equation. So master equation comes from mean field games, or optimal transport. So solving a master equation. Now we're in the game. China's an expert. China's a leader in this, because master equations have a whole bunch of partial differential equations. They're collections. Hamilton, Jacobi, Bellman equations. You stack them together, you get this system of partial differential equations you have to solve. So these are used throughout economics, finance, machine learning. And there's leaders. One of them's my friend Yucheng Zhang, just graduated from Princeton. He's a leader in this. The whole goal is to use AI and deep neural nets to solve master equations. So how good are they? So what's people found is they've used master equations to. So this is the frontier of economic theory and econometrics. This exactly. So they use AI. So what have they found? So what the promise and the challenge is AI can manage the curse of dimensionality. So anybody who tells you they've solved the curse of dimensionality, don't believe them. It's a complete bluff. And they're either cheating or they're assuming the answer somewhere, including some very good friends of mine. Okay, yeah, and they'll tell you where they put it. So it's shrewd dimension reduction. It's very shrewd dimension reduction. So you solve the curse of dimensionality by ignoring it. Okay, so what happens is, so here's what I learned from this conference, the best people. AI won't do it by itself. If you just ask AI to do it, I don't care, ChatGPT 4, 5, or 6, it will not do it. It'll give you crazy answers. What it takes is an expert who intervenes and tells the AI, no, don't go off in that direction. Go off in this direction. Now, where does that come from? That comes from the person knowing a lot of economics or mathematics or something about the problem. So that's why Xiaohong Chen can write a great econometrics paper, and I can't. It's that step. So this requires lots of high-skilled human model-specific talent, training-specific talent. So now you can ask, is this slide pessimistic or optimistic? Long Chen said, is it pessimistic or optimistic? It all depends. It's massively creating a lot of really interesting new jobs and destroying some old ones. Okay, so AI and jobs. So this is a hot question, and now, there's a little evidence. So this is an old question. So software is AI, in my opinion. So will software replace people? And there's evidence about that because software is growing. So here's what's true. And this got asked in somewhere, Long Chen and I were just an hour ago. Is software eroding labor share? So at least in the United States, but also in other countries, labor share of output, labor share of GDP is declining, and capital share is increasing. This is a very Marxist or Ricardian or Adam Smith. Who gets the returns from? So in the United States, it's been declining. Now, reservation. How is it measured? The United States has a crazy tax code, and there's some people who say it's illusory because there's some stuff that's called as capital and not as labor. And why would that be? Because the U.S. tax code taxes labor a lot more than certain kinds of capital, and there's smart people accountants who can tell you how to reclassify. Okay, but subject to that, many people, despite that, they think labor share is declining. It's controversial. So, but guess what? Capital and labor are heterogeneous. There's different kinds of capital, and there's different kinds of workers. And even within economics. So they differentially use equipment and software. Different workers use software and equipment different. Jiahong Chen just uses a paper and pencil, and I use Python. So it's but we're both doing the same thing. So technological change has manifested itself more and more in improvements in software. Equipment prices have been coming down, but software prices have been coming down even more. Okay, and like I'm a producer of software, I give it away. So there's lots of open source software. So prices of software have been declining faster than prices of equipment. Now, if you're a production function person, we use a very old idea of a paper Arrow and Solo wrote together. If Arrow and Solo wrote a paper together, read it. It was about a production function with elasticity of substitution between factors that didn't have to be one. The early CES production function. So software is replacing some kinds of tasks and jobs, and labor share has been declining as software produces substitutes for labor, and it actually raises firms' market power in some models. So it raises their marginal costs and is a force for profit shares to increase. So there's a new paper hot off the press by Aum and Shin, and they not only have a theory, they have extensive data from Korea where this has been going on. And they estimate this production function, and they estimate elasticity of substitution. So that's a state-of-the-art paper. So I think I've said everything I'm supposed to say. I have backup slides, which are great, about digital finance. But I think I'll there's a lot to be saying about digital finance, but it's kind of repetition. So you could ask what's new and what's old. Since we're in China, the activities are really old. So there are lots of stuff we did with paper and pencil, ledgers, banknotes and currencies. So what's digital finance? We do the same thing with ledgers and currencies. We can do them faster and much bigger, and that unleashes opportunities for applying some really great economic theory that comes from game theory and reputation. I'll just stop there.